Hello everyone, my name is Fernando Valverde. I am a software engineer based in San Jose, Costa Rica. I work predominantly in Ruby and Ruby on Rails, but I've been a Crystal enthusiast for a few years now. I'm very happy to be here sharing some of the learnings and stats I got from a Crystal web server that plays Battlesnake. So what is Battlesnake? In short, you can tell it's a video game. To quote the team behind Battlesnake on their website, Battlesnake is a multiplayer game where your code is the controller. All you need is a web server that responds to the Battlesnake API to play for you. Just a quick note, I am not associated or sponsored by the Battlesnake company or their team whatsoever. This is just where two passions collide. This is what the game looks like. Each Battlesnake is controlled by a live web server, and the code each developer wrote is what chooses their movements. The objective is to stay alive for as long as possible. You have to avoid collisions, you have to avoid the board limits. You can't go outside the board, otherwise your snake will die and you will lose the game. Each turn your snake loses a little bit of health, and food spawns randomly, and that will replenish your health. You can also die from starvation, so you can't fully forget about your health. You need to keep on eating every few other turns and continue playing. How did I build this web server? Given that I have a strong Ruby background, I chose Camel because it felt like a very straightforward implementation to have. Being inspired by Sinatra, I found it pretty easy to pick up, and the nitty-gritty or the more nuanced details of this implementation was going to live elsewhere, not that much in the Battlesnake API implementation. That is pretty simple. My main objective was to end up with reusable building blocks using object-oriented programming design patterns. I wanted to allow myself as much experimentation, to play with. I learned along the way that once you start playing Battlesnake and you make a change, you deploy something different in your Battlesnake, you have to wait a few hours, probably even better to wait until next day and see what that difference made, whether it was positive or negative. What change you deployed would actually affect your Battlesnake performance. You end up learning a lot about patience here, but it's a lot of fun and rewarding process, I would say. This is what the Battlesnake API looks like. It's 4 endpoints, pretty straightforward. And this is what the implementation looks like for me. There are, of course, a lot of different web frameworks for Crystal. I just chose the one that was probably most straightforward for me. And if you are a little experienced with Sinatra or Camel, you can tell this is the DSL you would use. A get endpoint with a strategy parameter, and this was done this way so I could have a bunch of different strategies work from the same executable. The reason for this is that I could put multiple multiple strategies to play against each other locally. And also I can have a web server that can play multiple strategies without having to recompile or have any other weird implementation details, I would say. But this is the base of each strategy, and this is where you put out some metadata for your web server, and you can customize your color, head and tail, and other details. These two endpoints mark the start and the end of a game, and this last endpoint is probably the most important one, and this is where the Battlesnake server or the Battlesnake host that's hosting the game will pass on to each of the Battlesnakes on the board, and it will tell them, this is your context, this is the board, this is where all the enemies are located, this is where the food is at. Now you have to pick a move out of that. A quick overview of the project structure. That snippet of code lives in the app.cr in the source folder. It's a very simple and small web server implementation. And the devil is in the details, I would say, because all the logic lives elsewhere. The strategy module holds all the different strategies that I've been building over time, and these strategies are what I meant in the beginning about that was my objective at the beginning, to have a bunch of reusable mix and match strategies that I could lay upon and just start building with. For example, this is the random valid strategy. So in order to work with strategies, I built an abstract class as a base strategy. The initializer will come and initialize your context, and every strategy will have to implement the move method. This is where you process the board, do all the logic you want to, and then pick whatever move you want. Up, left, down, and right are the options, and it looks very simple, but it's got quite a rabbit hole down where you can just lose yourself in endless strategies and ideas. That's the beauty of it, I would say. For example, this random valid strategy, you ask the context on line 4, what are the valid moves for your snake, and just pick a random one if there are any. So that is what the random valid strategy looks like. If there are no valid moves, just move up. Now, this context and all these classes have helper methods. When you arrive at a strategy, you rely upon these classes from the Battlesnake module to make your decisions. You build a context out of the JSON payload that the Battlesnake host web server sends you. And the context has the board has all the snakes. The snakes are a collection of points, and so on and so forth. That is how the logic is just built upon. I also wanted to share a little bit about the things that I use, the Crystal standard library modules that I implemented in order to make this implementation of the Battlesnake API. The JSON serializable module is the module that allows you to parse and generate JSON documents. This is something that almost any project as a web server will have to use, and this allows you to get a hold of a bunch of helper methods. For example, on the bottom, you can create a Battlesnake context from a JSON payload just by including the JSON serializable module and adding some annotations for the fields that you want to populate. The Battlesnake point includes the comparable module. This is a module that allows custom classes that you implement to be sortable and to be comparable in general. For example, a big use case for this is sorting classes within an array or a set or any other data structure that you want to use. As long as it's comparable, you can just manipulate it in a different and better way. I have my Crystal web server deployed to a platform as a service. I am currently using DigitalOcean, but any platform as a service solution out there that supports Docker would probably work for this. This project comes with a Docker file that will build your app in a relatively efficient way, and you will end up with something that you can deploy upon each commit, similar to what Heroku or lots of other platform as a service solutions out there provide. One of the main things that I wanted to implement in this project was open telemetry, because some other rule that I didn't mention at the beginning was that Battlesnake enforces a limit in how long it will wait for your response. So you have to respond within 500 milliseconds or so per each move. Having implemented OpenTelemetry and using Honeycomb IO for processing the data, I could tell and gather a few stats that were pretty interesting to me. With the basic solution I had for the Battlesnake API, I was getting about 76,000. In this time frame, I found 76,000 HTTP requests. The P50 duration in milliseconds was 0.32. In P95, it was 2.1, and P99, 3.1. All these milliseconds, so this is pretty great performance, I would say. Then the next logical step for me was to integrate a database. I wanted to store all the data per each game, per each turn that my Battlesnake was playing, so I could learn from it, so I could, do any other thing that I wanted. I implemented the Jennifer CR shard, which is pretty great. I fully recommend it. Again, there's lots of other frameworks out there for ORMs, but Jennifer was pretty nice. It's based on or inspired by Active Record. There are migrations, and this is what the model looks like. So just a pretty great experience from my end. Of course, there's some performance penalty from using databases compared to just processing and responding on each HTTP request. So in the top, you can see the time it was responding without any database integration, and after it was implemented, it bumped up quite a bit, especially in P99. So my next logical step while I was continuously learning in this project was to implement background jobs. I implemented the mosquito shard in order to persist data asynchronously instead of persisting the data before or during each HTTP request. Mosquito is used in lots of different web frameworks, so this was just my implementation of Mosquito within Camel, but Lucky and Amber and probably other web frameworks have, if not Mosquito, another solution for background jobs. And this is what it looks like, and this is what the job itself looks like. It's pretty straightforward, I would say, if you have some web development background and some experience with it, but overall it was a great experience as well. And this is the comparison of the performance from each. You can tell from the top without persistence, middle with synchronous database persistence, and the bottom using Mosquito to store the data in the database asynchronously. I basically arrived to a comfortable place where I was doing less than 10 milliseconds each response on P99. So it was a great learning experience of all these different building blocks for web servers in general. Now, when I started diving deeper into heuristic algorithms, you have to just jump into uncharted territory or some interesting and different ways of thinking. There are a lot of algorithms already, I would say even perfected out there from the data or computer science theory. For example, the A-star search algorithm, that is a graph traversal and path algorithm. This algorithm allows you to find the closest route to get to a destination. Some interesting fact about it was that I implemented the priority queue from Spider Gazelle project to make it a little more performant, but this basically allows us to find the closest food on the board. This is a simple strategy that chases whatever food is the closest to your snake. You use the A-star algorithm on each food, and that's what you pick, the closest one. Other utility algorithms that I have implemented in this project are the flood fill algorithm. This algorithm allows you to understand how much open space or open area you have in a specific point on the map. So this little animation out there tells you what, like from a starting point, how many blocks you can actually arrive to. This is useful for finding small enclosed areas. So this other strategy on line 36 tries to just calculate the flood fill on each valid move. This means that if your snake has to pick between left and right, it can avoid picking whatever enclosed space it would be on the right and pick left, for example. Now, with all this work done in the project, I was looking for a way to also document the project. I relied on the built-in docs feature from the Crystal language itself that would automatically build a static website for your docs. This comes in very handy, and especially when used along with the GitHub pages, you know, it ends up being a very easy to use documentation solution. You make sure your code is documented in line, and you end up with a GitHub page that's hosted for free. This is what the leaderboard looks like for me. The place that I'm at is probably not where I want it to be. I wish I could have just made it a lot better by now, but I'm still working on it, and this is just a continuous, just something I need to continue working on, and you know, it's a great learning experience, I would say. There are about 200 or 250 snakes on the leaderboard, so this 50-something place is not terrible, but yeah, the next steps that I was working on, and I'm still ongoing experimenting with it, are using neural networks. Given that I have about 500,000 turns stored as a data set, which include about 1,800 games won and 2,800 games lost, I would say that I have a good enough data set to start training a snake. But yeah, I have very little clue of what I'm doing. So what I did was I built a tool with option parser from Crystal itself, so I could just basically try out every single option, or not every single option, but a bunch of different options in parallel. This is a little bit of the code. It's maybe a little difficult to understand, but it's basically using fibers to work in separate threads for training. The network training is done in parallel, and this is what it looks like. So I can train a neural network using a bunch of different parameters, and at the same time have a bunch of different other parameters training other networks. Finally, the development and contributing to this project is always welcome. I had a lot of fun learning and experimenting with all this. So if you are interested in playing with Crystal and playing with Battlesnake and learning about each other along the way, you can find my project out there on GitHub. It's fully open sourced, and you can take it as inspiration or play around with a different implementation. It's all up to you. Thank you very much for your time, and it was great to be part of this Crystal conference along with all of you.